Hello there. My name is Cynthia Nanjala. I am a podcaster working with Wonder Properties Kenya, and welcome to the Wonder Property Kenya YouTube page. Please hit the subscribe button and the notification bell so that anytime we're uploading anything, you are the first person to know. Now, today we're outside, guys, and I'm in Westlands, Brookside Road, near Brookside Gardens, and I'm just outside the GAIA Brookside, the 3, 4, 5 bedroom apartments that Wonder Properties is currently developing. Now, we are here because we're here to talk about something crucial, and I'll be meeting one of the key persons who's at the center of this particular project. We'll talk about the developers, we'll talk about the salespeople and all other teams, but also one key aspect is on safety and quality control. So we'll be speaking to the Engineer Paul Kimani, who will be joining me in this particular episode, so that we can all go through these safety standards and quality control measures that they take on such a massive project. So we'd love to hear more of your views and your comments, and because this is one of a kind, I haven't seen it being done anywhere before. This is one of a kind, so I'd love to hear from you. So come on, let's go meet the team, the engineer. All right, so ladies and gentlemen, as promised, I'm still at GAIA Brookside, a 3, 4, 5 bedroom apartment that is currently being constructed along Brookside Gardens in Westlands. And as promised, I'm not alone. I'm with Engineer Paul Kimani, who's the site engineer for GAIA Brookside. Thank you so much for your time today.
Thank you.
All right, so for many people, they may be wondering, what exactly does a site engineer do? Do you just go to the site and you look at it and then go? What exactly do you do?
Yeah, thank you for having me. My name is Engineer Kimani. I'm a registered civil engineer and an accredited site supervisor by the National Construction Authority, and I'm designated as a site engineer GAIA Brookside project.
Yeah.
So, like you asked, site engineer is a very crucial role in this construction field, because it's the bridge between the consultant or the designer in the office to the implementation.
Right.
Because sometimes back they realize there is a need to be able to connect in between. Rather than being in the office the whole time, you have people on the ground who are able to understand the engineering principles, to be able to understand the engineering drawings, and then implement them, being there full time.
Yeah.
We do have so many roles that we play, cutting across planning, cutting across setting out, and cutting across safety standards and also the quality control.
So, engineer, in your line of work as a site engineer, who are some of the people you work closely with, especially just from what you've explained of your day-to-day work?
So normally we have different stages and different team members in overseeing the project to implementation. We have the architects who ensures that we have the floor plan as per the drawings.
Yeah.
We have the structural engineer who ensures that the building is standing by doing the rebar work and all that. And then now we also have the project manager, the one who is overseeing the project at whole.
Yeah.
And then we also have the subcontractors who we've been able to subcontract to be able to carry out the basic works. We have formwork, those who are able to hold temporarily the structure before we do the casting.
Yeah.
We have the steel reinforcement fixers and subcontractors who ensure that now the rebar works has already been done. And then we have the one who cast the floor. Later, when we start bringing out the wall partitioning, now to give the look, to give the room, to give the structure, the defined room, the unit, the everything. We have those wall masonry inspectors. So we work with them directly. We also have now the skilled team. We also have the unskilled team. So it's a communication in between different partners for this project.
And one of the other questions many people may also ask is, what is it about your job that many people may not know that you do as a site engineer? They may not think, that doesn't fall in your category.
So many people think that the work of site engineer is just about the drawing and concrete and all that.
Yeah.
There's so many things that revolves around that. There's a normal statement that we say that failing to plan is planning to fail.
Yes.
And so most of my work is to be able to foresee and be able to plan early in advance, so that if you see that slab over there, it's not just by default, it's something that you have planned for.
Yeah.
So I have to look at the drawings prior be able to see whether there are defects, there are things that are not maybe on point, be able to communicate to the architect and the structural engineer to ensure that everything is on point. So before I give the drawings to the subcontractors, the work is well planned and everything is taken in place. The other thing people don't realize is our aspect of imagination. I like to think that engineers don't have the five senses. They have six senses. We have the sense of imagination, the aspect of changing lines to walls, numbers to windows and all that. Yeah.
Engineer, we also appreciate the fact that we've got a huge workforce working here right now, and it's a huge number. So, what are some of the safety protocols or procedures you've put in place such that on a day-to-day basis, when they come here, there's a routine of how or what they do to ensure that they're safe?
Yes, we receive a high number of people coming in, and so the need to control how they get in and whether they have the right things is very crucial.
Yes.
Where once they get in, they are checked here, and then they are given the PPE kits, the standard one. And now, based on the work they're going to be doing, they're going to be given even more. If they're working on steel bars, we give them the gloves. If they're working on machines with high noises, we give them the ear muffs and all that. If they're working on cement and other related issues, we give them the mask.
The mask. All right. All right, this is a construction, and so minor injuries may be quite unavoidable. So how do you deal with that, especially for the workforce?
Well, we work very hard to ensure that we have zero cases of injuries. Maybe of one issues out there, they do happen, and we have people get injured. But I want to appreciate the fact that we've not had any major injury on anyone. And so what we do, we've devised a booth for ensuring that we do the safety kits and all that one is taken care of and given the first aid quick fast. And in case of maybe another medical issue, it's located on a very strategic point near the gate, so that in case of even a major, if it comes, we are able to deal with the person, and the person is able to be taken to the hospital quick fast. But we don't anticipate, we only plan for that.
All right, so Kimani, here we are now. We've come now to a different side of the GAIA construction, and we're here to talk about the quality control, right? Which I believe is important for any developer and even for engineers. Talk to me about concrete reinforcement, and what are some of the technologies you're doing to ensure that you have that sorted out?
Yeah, thank you for the question. Well, the way we build, or the way the building is based, is on the concrete technology. The reinforcement concrete, that's what this building is standing on. We from other projects, you may have wood, people go with wood, other people go with steel, but for us we deal with concrete and reinforcement. That's what making GAIA be what GAIA is. Now, when that is very crucial, there's a need to ensure the quality of the concrete that you are doing. And so cutting across from the mixed ratio to ensuring that you get the right standard and also the placement and all that. In one way to be able to control that, after every area has been casted, we do what we call the cube test. When you're doing the casting, we do the slump to ensure that there's a proper workability. We also ensure that we do the cube test now to ensure that the strength of the concrete is achieved. Yeah. So what we do normally after we prepare them from the boxes you've seen, the steel boxes you've seen, we're able to make something of the sort. It looks like this. You've seen it. So once we've been able to do this, we cure it for 7 days, and then we take it to the lab. For every given cube, for every given area, we make about 3 cubes to ensure that it's casted within different dates, from date 7, from date 14, and all the way to date 28, when the cube matures. Once the cube matures, we can be able now to test for the strength of the concrete, and whether that one has passed as per the planning, like I said earlier. So if we had targeted a class 35, the cube should achieve 35 or even more in most cases. And in case on worst case scenario, of which never happens most of the time, in case the cube fails, we also do what we call the in situ testing using something called a rebound hammer to ensure that what has been placed on the ground now achieves what is expected.
Yeah.
And in case now, even on our side, that even doesn't achieve, we have to demolish that part and redo it again, because safety and quality assurance is paramount.
Is paramount.
Yeah.
Who is in charge of enforcing, this concrete testing?
Yeah, that's my work.
All right.
Yeah. Ensure quality. That's one of my key aspects, to ensure quality, not just to implement, but to ensure the proper execution of every given project as per the engineering standards of which we go to. So we ensure that the cube tests are ready. When the result comes, we're able to engage the project manager on this, and this is happening. Yeah.
So we are at a center of a very, very busy place, and most of the time when I come here, this is where I meet the people first, and then I move up to the other floor. So what exactly happens here? Because I can see, things are moving up, coming down. What exactly happens here?
Yeah, this is a centralized area, and if I was to say this, if building was food, then this is the kitchen. This is the kitchen. Yeah, we have a bunch area over there. And like I said earlier, our building technology is concrete, so it's reinforcement concrete, concrete. So we make it over there. So material testing is apart from the cube itself, apart from the concrete itself, it's also very crucial to test the materials to ensure that they are right. Yeah. When the ballast comes in, the one on the black is called the ballast.
Yes.
You come in, you have to check whether they meet the quality that you want, the sizes, the number of the sizes you want. Are they porous? If they are porous, we allow them to leave. If you look at the side on the other side, we also look for other different aspects. The aspect of the siltation content, whether the silt content is quite high, and is it suitable for casting and all that. Others use them for plaster works, but for concrete works, you want to get the right materials. We use the two. We have the river sand on that side, and you have the black one for the casting.
What's the difference, you say?
The difference is one, the abrasion level.
Okay.
That one is quite high. This one is quite compact. And so because we need to have all those, because basically concrete is made of three parts. We have the cement itself. We have the fine aggregates, that's the sand, and then we have the ballast on the other side.
Right.
So we ensure we balance in between the two, because you realize we use very critical classes. We have class 35, we have class 40 that requires specific materials in terms of the fine aggregates and so on. Due to, you see, the thing with the sand is that they are tested on different levels, majorly on texture and others on silt content. For the silt content, we use water. We allow it to settle for a moment, and then you can be able to tell the percentage of the silt content. We also look at the texture, whether it's fine and all that, so that everything is on point. For this one, you will feel that is quite thinner. And this one is so good for plaster works. And also we also do some we also add them on concrete also to ensure the compactness of it. So now if you feel this one as compared to the other one, this one is called the quarry dust, and their particles are quite bigger as compared to that one, and the abrasive levels, you can feel how abrasive they are really hard, and they are very important when doing the concrete now, when you're mixing the concrete now.
Are you able to do these two particular types together?
We use different ratios.
Oh, different ratios. Okay.
Depending on the need.
We are on the outside now of GAIA, right? And I can see a huge green net. I know for many people, they may always be wondering, what is the essence of this green net? And also, with the neighborhood and the surrounding, how do we also ensure that we don't disturb their peace?
That's an interesting question. And there's something about the net. The whole aspect of the net is to ensure safety, and especially for falling objects, and also partly on the people working on the building. Since it's a high rise, you see people can fall over, and it acts as a barrier for all that. One, the net has the reason why it's a code, how it's green, is because they want to be able to merge it with the environment. When you're doing the project, you don't want to have something that is red and then standing quite high, something that blends with the environment. But now, when it comes to this project, is that the developer, of course, and the team involved, they are very crucial in ensuring safety, and especially to those people who or where we're working on.
Yes.
You understand that Westlands, and especially where you're working as far as of now, you're working on a very tight space. We have neighborhood on every different side. So any crucial mistake on safety, you'll be affecting them in one way or another.
Yes.
So at first, you've been able to do the net, which is very crucial, double netting, if I have to say, so that even one net is not enough. So we're able to do two to avoid later cases of falling objects here and there. We also do those balcony-like structures. They are called, we call them fall arrest, to ensure that in case an object defies the whole aspect of it coming from that, the objects falls on the fall arrest, and then we can be able to take it from there.
All right. What about the neighbors? Does this also help the neighbors as well?
We are working a very unique project, where we are working on a very tight space. There's no room for errors. I mean, one error is going to be something you don't want to look into. And so that's the reason why we done the netting, and this one helps so much to the neighbors, especially the fall arrest, to ensure that even when an object defies the laws of the netting and falling objects, they are able to fall on that, and to ensure that the neighbors are well taken care of. That the project continues as if the neighbors do their things as if the project's not even there in the first place. So
thank you so much, engineer, for taking the time today to just take us through some of these safety standards and quality assurance procedures. And we can't ignore the fact that, people will be concerned about constructions because of buildings that are collapsing and the partial collapses. So perhaps what will be some of the emphasis that you would make, especially for developers and people working on site?
Wow, that's a nice question. I think I'll make two statements. One, I'll say that our greatest enemy is one who we were building and the stakeholders who are building and implementing the project. Our greatest enemy is assumption. When you assume one point or you assume one thing, then that leads to massive or catastrophic incidences that we've seen. Nobody wakes up today and feels, I want to bring down a building. It's something, he missed a bar, he missed a glass, he missed order. Number two, we've been trained to believe, and we've been trained to know that a collapse of a building is not an accident, it's a failure of process. When you fail at one process, it leads to the other, because you see, this whole structure is a system. It's been designed that one thing affects the other, and so when you miss one process, you're affecting the others and earning a hand-earned money. One thing I like about the developer, and the whole thing is he's keen, all his emphasis on qualities and so on. He's had the power to the fact that if that thing may cause an issue, let's stop it at that. That progress is not important if you're heading on the right direction. So when it comes to those issues, is that we need to look into it as a process, ensuring from the arrival of materials to the casting itself, to delivering itself is right. Every proper inspection, we have county inspections. We also have statutory inspections by the consultant. They come and check what are we doing. Like I said earlier, there's need to have a bridge between the designer and the implementation. So they come in and they look like, hey, is what we provided for you, is it what you're using it to be able to be? Thank
you so much, and I'm looking forward to come back when we'll be maybe 15 or 13 or 17 floors up already, right? So asante sana, we really appreciate it.
Thank you so much. Welcome again. And to all the people who are watching, I'd like to ascertain and to be very sure to give them an assurance that what you're doing here is quality, is sound. And when you come back again, you'll realize we'll now talk about more deeper things about the site and all that. And that this place is not just a place to come and just buy. It's a place you come, buy and live.
All right. Asante sana.
Karibu again. Thank you so much.
Thank you.